Welcome to the Logic Design and Microprocessor and Embedded System Lab. I'm going to show you a few things around here. This is one of my famous experiments which I use in the embedded system, in the graduate and in the undergraduate experiments. What we see here is motor control. We control the speed. And also we can change directions. And obviously we see a motion sensor. With motion, the light turns on and off. We have proximity sensor here that helps also turn things on and off just by touching. But what's so interesting about all of this is all these controls is managed by one single controller, and that is the 9S12NE for network enabled. This single chip microprocessor also has embedded web controls. So basically that's a single chip web server and microcontroller. And if you notice, this will be connected directly to the Ethernet, and you can do all this control through the web. Another experiment I can show you here is I'm using the same embedded system building block, which is again a full controller and an embedded web server as well. It connects to the Ethernet directly and a 9-volt supply, and then all the IOs are connected to it. This circuit is exciting a transistor that's being tested for IV characteristic. So sequentially we apply a sequence of currents on the junction and we read the voltage drop, and then we draw the IV characteristic. All of that is done right here in this box. Now how do we see it? We see it through the computer. So we log in again to actually active element.cse.fau.edu. Anyone can go there and you see the experiment. What you see here is actually a website, a web page which is loaded into that box inside the controller. And what we can do here, we can choose different the current on the base. Let's say we choose 10 microamp, and then we say run the experiment, and you see that this system here, which is right on the website, it applies incrementally different currents and read different voltage, and it draws actually the IV characteristic. So that IV characteristic is actually drawn in a website right in the box there. This is part of my research for remote laboratories. So basically students can log into this experiment, and every day we can put a different transistor and we ask them simply to test the IV characteristic of that transistor. And this is all done through embedded web controls. Another experiment, I had a graduate student build actually a speed controller or a speed measuring tool. The way he did it is we put two temperature sensors very close to each other, and then we apply the wind to that. Now based on the differential reading of the temperature, we can measure the actual speed. So this air, which is introduced by the fan, is actually running at a speed of 5.2 kilometers. This is another embedded system project. And of course, embedded systems, the sky is the limit. We have tons of different experiments and tons of different sensors and controllers. Welcome again to Embedded Systems.